Hello my dear students, welcome to the class of 11th English medium. The subject is statistics, chapter 3, measures of central tendency, brought to you by Vitan sir. In the last tutorial I gave you an introduction of the measures of central tendency and the characteristics of an ideal measure. Now in this tutorial we are going to start with the very first, that is arithmetic mean, also known as just mean. Arithmetic mean is the value obtained through dividing the sum of all the observations with total number of observations. Now this is a very straightforward definition, that is a mean, an average, which is obtained by dividing the total value of all the observations with the number of the observations. Let's suppose that x1, x2, x3, x4 dot 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 are the observations up to observation xn. That means, therefore, sum of all the observations can be written as sum of xi or summation xi. Okay. In the 10th standard, you might have learned that this is the sigma symbol. Yes, you are right. This symbol is sigma. But in statistics, in the commerce, we call it summation or sum of and not sigma, because in the 12th standard there will be another symbol which will be called sigma. So not to confuse between them, this sign is known as summation. So summation xi. Also, total number of observations is always denoted by n. So arithmetic mean formula for the variable x will be x bar is equal to sum of xi divided by n. A very simple, a very straightforward formula, summation xi divided by n. Now let us look at the formulas specifically for different types of observations, starting for row or ungrouped data. Now when the data is row data or the ungrouped data, what to do? Formula here is very simple, that is x bar is equal to summation xi upon n, where summation xi is sum of observations x1, x2, x3, x4 up to xn, while n is the total number of observations. So that's the formula for mean when the data is row or ungrouped. But then there is a shortcut method for that. This shortcut method is used when the value of observation is very big. Means this method is used to make the calculations easier. So when the values given in the questions are very big, for example in hundreds or thousands or something like that, so at that time doing oral calculations becomes difficult. And you should remember that these methods were developed in the era where calculators were not there. So naturally people used to do them orally or by writing them down on the paper. So shortcut methods were developed to shorten the calculations and make them easier. So what we do here, we take an assumed value a and it is deducted from all the xi's, that is all the observations, and what we get are the deviation, that is di. So an assumed value a is deducted from all the observations to get their deviation. Now remember, di, that is observation minus a, where a could be any value from outside of the data or inside of the data. That means its value could be from the data or from outside of the data, doesn't matter. You can assume any value for a, and the formula here will be x bar is equal to a plus summation di upon n. Okay, so I hope you guys are getting my point here, that whenever we are calculating a shortcut method, we deduct a certain value a from all the observations to reduce the value, and then at the end in the formula we again add that value in the answer. So we deduct a from the observations, and in the formula we add a in summation di upon n. Let's do some sums to understand this. We will start with illustration 1. The following data shows the number of scooters repaired daily at a garage. Find the mean number of scooters repaired daily. The number of scooters are given 7, 13, 4, 8, 6, 9, 10 and 4. Now what we are going to do, the total number of days are 8. As you can see here, 8 days, 8 data is given 7, 13, 4, 8, 6, 9, 10, and 4. So 8 data is there, and when we make a total of all those data, we get the sum of the observations, summation xi. So by adding all the observations, we get 61. So mean will be x bar is equal to summation xi divided by n, that is 61 upon 8, to get 7.625, and to round it up to two decimal values, 7.63. So we will write down a statement that the mean number of scooters repaired daily at garage is 7.63. Next, we will start with illustration 2. The rainfall in millimeters at 10 different places of a single district was recorded as follows, that is 126, 110, 91, 115, 112, 80, 101, 93, 97, and 113. We have to find the mean rainfall. Okay, now this is a sum which has big values, as you can see in hundreds. So what we are going to do, we are going to use the shortcut method to solve this. The observations are large, we will use shortcut, and for that purpose the assumed mean which I am going to take is 100. That means I will deduct 100 value from all the observations to make them smaller. I will prepare a table to explain that here. Rainfall in millimeters is given, and then I am going to find the D from that rainfall, that will be x minus a, where a will be 100. Now I will write down the original data in the table as I'm doing it right now, and then we will also require the total. Now I have to deduct 100 from all these observations to make them smaller. So I will deduct 100 one by one. So remaining values will be 26, 10, negative 9, 15, 12, negative 20, 0, 1, negative 7, 3, and 13. So when I make a total of all these values which I got, that is the total of the deviation, I will get 38. Now I will write down the formula here, but before that I should write down the total number of places, that is n is equal to 10. So I will be sure about it in the formula. Now mean is x bar is equal to a plus summation di upon n. The very important point in this chapter is to remember the formulas and when to apply them. There are many formulas in this chapter, and there are many places where you should apply them. So remember that. Try to make out a list of all the formulas wherever I am giving the formulas in this chapter, in this tutorials, in the upcoming tutorials. Just make a list out of them, and keep that list separate, and try to revise that list at least twice in a week. That way you will be able to remember the formulas at the end of the year. So write down the values. A is 100, summation di, that's the total of the deviation, is 38, and n is 10. So 100 plus 3.8 will be 103.8 millimeters. So the answer will be the mean rainfall is 103.8 millimeters. Next, I am going to start with illustration 3. The mean weight of group of 20 persons was found to be 55 kg. So question is directly given. Later it was discovered that one of them reported her weight as 45 kg, which was actually 54 kg. That means the one of the observations in the question itself was wrong. The wrong observation was 45 kg. Actually, the correct observation is 54 kg. So what we need to do is we need to correct the answer of mean. Now, how we are going to do that? Let's start. Here, x bar given is 55, and the number of people, the group of persons, is 20. So what we are going to do, first we are going to write down the formula for mean, that is summation xi upon n, which is actually given already 55. In this formula the value of n is also available, that is 20. So when I change the side of 20 to opposite, it becomes 20 into 55. So my total of the 20 observations I already have is 1100. Okay, so the total of the sum of the observations is 1100, but it includes the wrong value, which is 45 kg. So now I am going to correct this value. My aim here is to correct the value of mean. So to correct the value of mean, I need to correct the value of total. So the wrong total here is 1100. I will deduct the wrong value and add the correct value. That way I will get the correct total. So summation xi is 1100 minus wrong value 45 plus correct value 54. So the correct total is 1109. Now what I am going to do, I am going to find the corrected or the correct mean using this correct summation xi in the equation. So 1109 divided by 20 will get me 55.45 kg. So the correct mean, the correct average of the weights of 20 people is 55.45 kg. Okay, I hope you guys got my point here. After going through three illustrations of regular ungrouped data in the shortcut, let us start for the classified or the grouped data. Now you should remember from the second chapter that classified or grouped data has two types, discrete and continuous. And because it will be very long, I am only going to discuss discrete data in this tutorial. Continuous will be covered in the next tutorial. So I will start with the discrete frequency distribution formulas here. Now suppose x1, x2 and up to xk are the observations with f1, f2, fk as frequencies. As we know, the classified or group data has frequencies attached with the observations. That means x1 is repeated f1 times, x2 is repeated f2 times, and xk is repeated fk times. That's frequencies. So total number of observations in this kind of situations will be total of the frequencies. Okay, so total number of times any data is repeated becomes the n here. So n will be sum of all the frequencies. So n is equal to sum of fi. Okay, that is f1 plus f2 up to fk. So n here will be summation fi. And to find the total of observations, x is repeated f number of times. So to find the sum of observations, we are going to multiply x with its respective frequency and then total. So we will multiply x with its respective frequencies and then make total. So how it is going to happen? Sum of fi xi, that is the symbol for the total, will be f1 multiplied by x1, then plus f2 multiplied by x2 plus up to fk multiplied by xk. So the observations are multiplied with their frequencies and then totaled to find the total sum of the observations. So the formula here, which is going to be x bar, is sum of fi xi divided by summation fi, or sometimes also written as sum of fi xi divided by n. So you can use either of these methods to write down the formula. Now just like our ungrouped data, even grouped data has shortcut methods in which we follow the same thing, that an assumed value a is deducted from xi to find di, that is the deviation. But an added thing here is that if available, deviations are divided by a common factor c. Because it is a group data, there might be a possibility that the observation has a certain common factor which we can use to further reduce its value. So if we find some common factor between all the xi values, we can divide it by using a common factor c. So we can further reduce the quantum of the observations to make our calculation easier. How we can do it? D1 will be x1 minus a divided by c. Then D2 will be x2 minus a, again divided by c, and up to dk will be xk minus a divided by c. So this is how we are going to find our deviations. Now summation fi di will be something similar to summation fi xi, that is f1 into d1, f2 into d2, and so on up to fk into dk. So last thing which I need to explain beforehand, that n is something similar, that is the summation of all the frequencies, that is summation fi. So you can use n, you can use summation fi, it does not matter. So at the end, the formula here will be x bar is equal to a plus summation fi di divided by summation fi into c. As you can see, we are subtracting a, so at the formula we are adding a. We are dividing d with c, so in the formula we are multiplying d with c. So at the end everything is balanced. If I subtract something, I have to add it. If I divide something, I have to multiply it. And its opposite is also true. If I add something, I have to subtract it, and if I multiply something, I have to divide it. So keep this simple logic in mind and it will be easier to tweak with the formulas as much as you want. None of these formulas are written in stone. We can change the formulas, but we should keep in mind the balance of these formulas so that we don't get the wrong answer. Let us check out some sums to understand this better. I will continue with the illustration, that is illustration 4. The following table shows the number of children per family and we need to find the mean number of children per family. Okay, the table is already given here, the number of children that is denoted by X naturally and number of family is denoted by F. So number of children were 0, 1, 2, 3, 4, 5 and the total and number of family. This is given in the question itself. I am just presenting it in some better graphics. 4, 8, 23, 8, 6, 3. The total families are 52. Now we need to add a table value here. As you can see, number of children X and number of family F is there. So we need to multiply our observation with our frequency for the sake of calculating mean. So I will call it Fx, that is 0 into 4, 0, 1 into 8, 8, 23 2s are 46, 8 3s are 24, 6 4s are 24 and 5 3s are 15. So when you make a total of the Fx, it becomes 117. So let's just start with mean, that is x bar is equal to summation fixi divided by n. Here the n will be the total of the f column and summation fixi will be the total of the fx column. So just write it down, 117 divided by 52, round figure value is 2.25. A very easy sum here. The mean for number of children per family is 2.25. So on an average, a family has 2.25 children. Now naturally children couldn't be divided into decimals, but this is just an average value. So don't mind that. We will move forward with the fifth illustration. The time in minutes taken by a bus to travel between two towns on different days is given. We have to find the mean travel time. Okay, so the travel time here is our variable and the days here are our frequencies. So I'm just writing down the data here as it is. Now if you look closely at the data, you can see again the data is in hundreds. And you should remember that when the data is in this kind of hundreds, we use the shortcut method. So before actually multiplying f with axis, rather we will start with the deviations, that is d, that is x minus a, and the assumed value I have taken here is 120. Now I have told you before, you can take any value from the data or you can even take a value out of the data. The value of a does not make a difference in your calculation. You can take any value. If you want, you can even take 1000, but just take into consideration that we are trying to make it easier, not harder. So take a value which is somewhere between the given data, so that way your values will be smaller. So something which is between the data is 120, so I have taken 120. If you want, you can take 100. If you want, you can take 130, 150, not a problem, but try to make it easier. So I have taken 120 here, so x minus 120, negative 10, negative 7, 0, 2 and 6. We don't make a total of these deviations, because if we make a total of these deviations, it will always be 0. Remember that total of deviations will usually be 0, but not this deviation from mean will be 0. Right now we don't need the total, so we are not doing it. Multiply f with d, so 7 tens are 70 but negative, 17 sevens are 119, 0, 20 and 30. So when you make a total, you get something like this, that is negative 139. So start with the mean, that is x bar is equal to a plus summation fi di divided by summation fi into c. Now you might be wondering, where is the c here? Of course c is not there. So when I have not taken any common factor, 1 is always the common factor. Okay, so just multiply it with 1, that's all. Now A is 120, summation FIDI is negative 139, summation F is 50, and the common factor is not there, so I have taken it as 1. Just to simplify this, and you will get 117.22 minutes per day. Okay, so the statement will be thus the mean travel time for bus is 117.22 minutes per day. Simple, right? There is nothing difficult here actually. Just rewind this video if you have any doubts, and you will understand that it is actually very easy. This will be the last illustration for this tutorial. Illustration 6. The price of an item changes from shop to shop. The following data is available. Find the mean price. So the price here is X because we have to find the mean price, and the number of shops is the F here. So I am writing down the price here. Now if you look closely at the prices, you will see that all of the prices are even numbers. Just look again. Yes, all of them are even numbers. That means even numbers can be divided by 2. So there is a common factor in all of these prices, that is 2. So I am planning on dividing these prices with that. So my D here will be X minus A divided by C, where A I am taking 220. It is something in between, and also from the data, so one of my data will become 0, easy to calculate. And I am dividing all the observations by 2 and FD. Okay, I think you guys are getting what I am trying to say here, that A should be something from middle of the observations, and C should be something which we can divide every observation with. Try not to get a decimal answers. If by dividing with C you are getting a decimal answer, don't divide it. It will just make your work harder, and we are trying to make it easier actually. So let us start. For example, 206 is there. When I subtract 220, I will get negative 14, and when I divide it with 2, I get negative 7. 212 minus 220 gets me negative 8, divided by 2 is negative 4. So continuing in this method, you will get the remaining values. Just remember, x minus 220 divided by 2. FD is just a multiplication of frequency with the deviation value. So 5 sevens are 35 negative, 8 fours are 32 negative, 9 ones are negative 9, 14 zeros are 0, 3 twos are 6, and 1 fives are 5. And when you make a total, you get a negative 65 answer. Moving on with the mean, that is x bar is equal to A plus summation Fi di divided by summation Fi into C. A is 220, FIDI negative 65 upon 40 multiplied by 2 is the common factor. So just to simplify that, and you get 220 minus 3.25, and that is 216.75. So the price of an item, the average price of an item is 216.75 rupees. Okay, my dear students, I hope you understood this concept. Welcome students to Vitan's Unacount Academy. That's better way to success for you. I am Vitan Vora, and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel, and also check out my other video playlist which you can see on the screen. Thank you, and I will see you in the next video.